Assalamualaikum warahmatullahi wabarakatuh. My name is Afif Nuqman bin Nur Azmi. My number country is CN200270. My SB is Professor Dr. Amir bin Khalid. Firstly, I want to thank you to my panel for giving me this opportunity to present my title project for PSM1 Bachelor Degree Project Research for the title of Investigation of High Blending Ratio of Ammonia and Biodiesel in Diesel Combustion. Okay, now I will begin my slide presentation. Okay, here is the list of the content, research background, objective, scope of study, literature review, methodology, experimental setup, expected outcomes, conclusion, and also the overall project plan. Okay, for my research background, my research especially is focused on the biodiesel blends varieties, which is in the study I choose was crude palm oil biodiesel CPO. Basically, crude palm oil is among the previous study top choice because it has it is renewable, safe, and easy to handle. In addition, it also offers far less carbon residues compared to petroleum diesel. It also blends well with other oils. Secondly, I choose biofuel variety which is B30 as my biodiesel blends because it reduces the diesel consumption greatly. B100 is not my choice because it will produce more pollutants compared to B30. Ammonia contains 3 molecules of hydrogen and 1 molecule of nitrogen. Hydrogen is the lightest gas which can transport electricity and molecules. Nitrogen is an element that is produced in all living matter. Nitrogen cycle are nitrogen fixation, nitrification, denitrification, decay, and lastly putrefaction. In this study, ammonia is chosen as a mixture for biodiesel blends because it has the highest capacity for hydrogen storage and also contains zero carbon. Other than that, this study also focused on the spray formation and characteristic by using ammonia biodiesel blends in combustion chamber, which can be seen in the diagram. Okay, here we can see the diagram, the combustion chamber. Okay, the spray that we form at the injector nozzle here in the combustion chamber, this is I will focus my study on. Based on my findings, there are several advantages and disadvantages of using ammonia biodiesel as fuel. Okay, the advantage are it is relatively high power to fuel to power efficiency. High alternative of 101, 110 to 130. Its limited flammability range. It could dissipate hydrogen at comparatively little money. It is safe in terms of explosion risk, and it does reduce the carbon dioxide. The disadvantage of the biodiesel ammonia, it produces high levels of pollutants, which is nitrogen oxide, hydrocarbons, and also the ammonia residuals that may cause harms to our lungs, and it generally low reactivity when used as a fuel. It has low ignition energy, which is ignition delay time is higher than other fuel, and it may cause the power reduction in the engine. So that is the advantage. Okay, next is the problem statement and objective. Okay, the problem statement of my research is to understand which mixture of formation gives better performance and emission reduction, which is ammonia, which the mixtures. Second one is the full usage of ammonia as a fuel is hazardous to environment. So we take a certain percentage of ammonia to be used in the biodiesel fuel. And the third one is the production of the nitrogen oxide emissions and particulate matter increased dramatically. So that's why we use biodiesel and we add a little percentage of ammonia. Okay, we may see the environmental effect because of the release of harmful emissions, which is hot temperatures surrounding, increased drought, flood, landslide, and also severe storms. We may take this as a precaution in the future to not make these situations happen anymore. So the objective of my study is to simulate the flow pattern of mixture formation of ammonia and biodiesel sprays in formation chamber using CFD software. Second one is to investigate the flow pattern and the spray characteristic of ammonia biodiesel blends. Okay, now I will talk about my previous study. Based on the previous study that I will talk about the scope. My scope of studies are firstly biodiesel blends. The full use is B30 crude palm oil biodiesel. Okay, the ammonia percentage varies at 2%, 4%, or also 6%. The blending ratios at 25% or also 30% by volume. And the parameters that need to be controlled was the ambient pressure, injection pressure, and orifice diameter. And how to get the data and the measurement, we use the Fluent ANSYS CFD software. Okay, next I will talk about the literature review, which include the previous studies of this title, which is ammonia biodiesel. Okay, the first one is Granel. Granel, for example, is gasoline and ammonia is just ammonia 10%. His finding conclude that 10% ammonia injection lowers in cylinder temperature by 50 Kelvin, which significantly lowers nitrogen oxide emission by 50% at all engine speed. The second one is Yapijirifu Dinser. Okay, the full example is said. His finding also state that the adding ammonia decrease the carbon dioxide emissions of the gasoline engine. Additionally, it had a considerable negative impact on engine power and efficiency. Okay, third is Mona Rosell. His findings are by reducing ammonia by 10% with hydrogen, dramatically reduce nitrogen oxide emissions by up to 40%. Okay, Louis, his finding efficiency is decreased by the high hydrogen proportion in the stoichiometry mixture, but the efficiency is increased when the equilibrium ratio is reduced. Okay, Lilly also stated that when ammonia was used in place of natural gas for more than 50% of the volume, carbon dioxide emissions were reduced by about 28%. However, the air-fuel ratio hit a high limit around lambda 1.5 when taking combustion efficiency and emissions into account. Okay, Rated and constant, he's finding that nitrogen oxide emissions dramatically increase when ammonia engine makes up more than 50%. Okay, we may see that Lee and Song also state that the same way, UTHM increasing the ammonia engine population for caused a 58.8% drop in the nitrogen oxide emission. Okay, basically in this literature review, there are about 12 studies. Okay, we can see the another 4. Okay, this one is the recent study about 2022 with Abdullah Emre Yusba and also Asbah Ahmed. Their findings are high combustion performance can be achieved by mixing with gasoline if ammonia is separated into molecules such as nitrogen, hydrogen before being fed into internal combustion. It's possible to produce hydrogen with high purity during the composition of ammonia. David Harris also stated in a house stable carbon-free power from ammonia, there is no carbon content in the system by using the ammonia. Arpele also stated that the geometry of ammonia spray differs from that of gasoline and ethanol. It is longer and thinner under most conditions than the sprays of the current fuel study. It evolves differently with temperature and change in air density. Overall, gasoline and ethanol have the same characteristic. Okay, and lastly, Arpele also stated that the temperature and air density sensitivities were explored and showed that ammonia is more sensitive for both parameters other than other fuels. Okay, that's for the literature review. Okay, let's move to the methodology. This is the methodology for my research. Firstly, I need to understand the project title. Then I need to understand how to make the simulation using ANSYS software. Then I continue with the research about the title project. Then after that, I did the modeling based on the project requirements. And then I do meshings. I set the boundary conditions, and then I set the parameters such as temperature, density, and also injection pressure that will be used in the simulation. Lastly, I do the simulation running, which I need to be conduct on the PSM2. Currently, I still trying to run the simulation. Okay, so this is for the methodology part. And then let's move to the experimental setup. Okay. The experiment based on this study, currently I use the RCM machine, which is a rapid compression machine. Okay, we can see here that the red circle here, it shows where the research takes place. We can see that here there is an injector nozzle before the combustion chamber in the RCM. Then we can see that here this is combustion chamber. Okay, here is the combustion chamber. And then at the right side of the screen, we can see that this is the analysis for the CFD for this region. And then the below picture, the below one is the half section of the injector and the chamber itself. The ambient pressure that I used in the study is 1 atmospheric pressure, which is equal to 0.1 megapascal. And the injection pressure used according to the previous research, which are 13, 16, and also 19 megapascal. And lastly, the ambient pressure, lastly the ambient temperature is set to 800 Kelvin. Okay, expected outcomes. What I maybe expect from this research myself. Okay, from this research, I had made several expectations after obtaining the best ammonia biodiesel mixtures for B30. So the first one is it will produce a better and finer spray atomization for harmful gas emissions reductions. It will produce a better engine performance for aiding the industry of automotive in the future. Okay, secondly, it will produce a higher rate of combustion that increases the efficiency of combustion process. When we get the uh, desired value for the result, we can see that it will increase the efficiency of the combustion process from the complete combustion itself. Okay, and then it will increases the consumption reduction of the biodiesel fuel that we use nowadays, which is B5, B10, B30, B20, and also B100. We will decrease the use of the diesel used in that biofuel plants. Okay, before that, we can see that what I expect from my research, it will reduce the particulate matter emissions such as hydrocarbons, nitrogen oxide, carbon monoxide, and also carbon dioxide. These four particles will be reduced greatly after this research has been done and being applied in the automotive industry. Okay, for the conclusion for this presentation and to conclude for my research for PSM1, I need to say that the ammonia that we study and I study is a promising alternative fuel mixtures that can replace current fossil fuels, which is ammonia biodiesels. We can add ammonia mixtures in the blends so we can reduce all the harmful metals in the exhaust gas emissions. Okay, so this study is also aiming to investigate the mixture formation of ammonia biodiesel blends at high ratio. Okay, and lastly, the experiments and research will be done to meet the requirements to get the improvement on the emissions levels based on the spray characteristic, as well as to study the atomization process of the spray and the droplets from the use of ammonia biodiesel blends fuel in the combustion chamber itself. Okay, last but not least, I will explain about the overall project plan for my PSM1 to the panel and also to the supervisor. Okay, firstly, at week 3, I got to decide a topic, and for the proposal submission, I get to submit at the week 4. And then I do Gantt chart, and I do research on the week 5 until the week 8. I do the scope of project, expected result, I do the simulation, a little of simulation in the methodology part from week 10 to week 20, I do the simulations. And then to submit the PSM1 draft, I submit it on the week 13. And for lastly, for the PSM1 seminar will be held on this week, okay, today. So it's on the week 14. So thank you very much for my supervisor and my panel, Dr. Azri for hearing, Dr. Azri and also Dr. Nurizam for hearing me this explanation of my research title project. So thank you again. Assalamualaikum warahmatullahi wabarakatuh.